Good morning everyone. In this video I'll be talking about the quantitative measurement of light. Okay, so what is the quantitative measurement of light? Now this topic or this video is based on the book Clinical Optics by Elkington. So the quantitative measurement of light is done in two ways as it is written over here. First is the radiometry and the other is the photometry. Now this topic could be a bit confusing because of the different nomenclatures which are used. Now what the radiometry is? Radiometry, it quantifies the radiant energy in all parts of the electromagnetic spectrum, right? So whatever the wavelengths are present in the electromagnetic spectrum, the radiometry quantifies all of it. Okay, and these are the absolute values. Keep in mind that these are the absolute values, whereas in the photometry it it quantifies the part of this electromagnetic spectrum in terms of the visual response that is produced. Okay, that is the or in other words it talks about the spectral sensitivity of light, and hence the photometric values are more commonly used in the visual sciences. Okay, so radiometry, it measures light in terms of how much is emitted from a source, that is the flux, the intensity of the light that is emitted called as the radiant intensity, the amount of light which is falling on a surface. Okay, the amount of light which is falling on a surface, that is the irradiance, and the amount of light which is reflected from it, this is the radiance. Now the equivalent photometric values of it is the luminous flux, okay, the luminous intensity, the illuminance, and the luminance. Okay, luminous flux, that is the amount of light which is emitted in and how much visual response it produces, that is the luminous flux. The intensity of it is luminous intensity. The light falling on a surface, that is the illuminance, and the light which is reflected from it, this is the luminance. Now these two values, these the radiometric and the photometric values, these are related by the luminous efficiency of the radiation. Okay, so these two values, they are related by the luminous efficiency of the radiation. So this is a, you can call it a joining factor, or you can call it a conversion factor. This luminous efficiency of the radiation, this is the conversion factor. Okay, so this is the okay, so this is a conversion factor which is specific for each wavelength, and it is determined by the sensitivity of the light to it. Okay, so the peak photopic sensitivity of the eye is for a wavelength of 555 nanometer. So this is the peak photopic sensitivity. Okay, so the peak photopic sensitivity of light is for a wavelength of 555 nanometer. This is the yellow green. Okay, now at 555 nanometer, 1 watt of monochromatic light has a photometric equivalent of 685 lumens. Okay, so at 555 nanometer, what they are saying, that 1 watt of monochromatic light, keep in mind the eye should be monochromatic, so 1 watt of monochromatic light has a photometric equivalent of 685 lumens. Okay, so this wavelength has the maximum luminous efficiency. This 555 nanometer has the maximum luminous efficiency. Okay. Now this eye, it is progressively less sensitive to wavelength towards each end of the visible spectrum. Okay. So if we draw a diagram, so the it goes like this. This is the 555 nanometer. Okay. So this is the peak photopic sensitivity, and on the both sides of it, the eye is less sensitive to wavelength. Okay. Okay, now this conversion factor, it falls 0 outside the range of 400 to 700 nanometer. Okay, outside this conversion factor, that is the luminous efficiency of the radiation, it falls to 0. And why it falls to 0? Because the eye is not able to see the wavelength outside this 400 to 700 millimeter nanometers zone. Okay, so the total flow of light emitted in all direction from a source is called as the luminous flux. Okay, so this is the total uh, flow of light which is emitted. If it is measured, if measured in watt, or luminous flux if measured in lumens. So this is measured in watt and this is measured in lumens. So okay, so what it is कि एक सोर्स से सारी डायरेक्शन में कितनी लाइट एमिट हुई है, ये हमको क्या बताता है, ये हमको अगर हम इसको वॉट में मेजर करते हैं तो ये हमें लुमिनस फ्लक्स बताता है, तो ये हमें रेडियंट फ्लक्स बताता है। आई एम सॉरी, अगर ये हम इसको वॉट में मेजर कर रहे हैं तो ये रेडियंट फ्लक्स बता रहा है, और अगर हम इसको लूमिन्स में मेजर कर रहे हैं तो लूमिनस फ्लक्स बता रहा है। ओके, द इंटेंसिटी ऑफ लाइट एमिटेड फ्रॉम अ सोर्स इट इज़ अ मेजरमेंट ऑफ द फ्लो ऑफ लाइट पर यूनिट सॉलिड एंगल ऑफ स्पेस एक्सटेंडिंग अवे फ्रॉम इट। ओके, सो इंटेंसिटी क्या होती है? इंटेंसिटी होती है द फ्लो ऑफ लाइट पर यूनिट solid angle of space. Now we talk about the intensity. Intensity is the flow of light per unit solid angle of space extending from the source from which the light is coming out. This is called as the radiant intensity if it is measured in watts per steradian, or luminous intensity if it is measured in candelas, that is the lumens per steradian. Okay, so watt per steradian, so this is the radiant intensity, or if it is measured in lumens per steradian, then it is the luminous intensity. All right. Now what is steradian? Steradian is the unit of solid angle which resembles a cone and defined as the angle at the center of a sphere with substance and an area on the surface of the sphere measuring the square of the radius. Okay, so it is the unit of solid angle. And it resembles a cone. So this, okay, ठीक है, angle at the center of a sphere. If this is a sphere, so this is the center of the sphere, and this is the angle at the center of the sphere with substance and area on the surface of the sphere. So this much of area is subtended on the surface of sphere, measuring the square of the radius. So this is the radius, this is the angle, and this is the surface. This is the steradian angle. Now since the surface of the sphere is, what is the formula for the surface of sphere? The surface area of the sphere is 4 pi r square. Okay, so what it is this is the surface area of sphere. It follows that a point source whose luminous intensity is 1 candela, it emits a total of 4 pi lumens. Okay, now the original unit of luminous intensity. So if we talk about the unit of luminous intensity, okay, it was candle. It was candle. Okay, because of the emission from a wax candle. So imagine this is a wax candle and this is of standard composition. So how much light is emitted from it, that was measured as the luminous intensity. Now attempts to produce a more uniform and the precise source of light by which others could be measured, it led to the current standard unit, that is the candela. Okay, whereby the luminous intensity per square centimeter of a black body radiator at the freezing point of platinum is defined as the 60 candles. Okay, how we define a more specific unit is, that is the candela. What we use now is candela, candela. It is the unit of the luminous intensity. And what it is? The luminous intensity per square centimeter. The luminous intensity per square centimeter of a black body radiator at the freezing point of platinum. कि प्लेटिनम के फ्रीजिंग पॉइंट पर अगर हम लोग एक ब्लैक बॉडी है जो कि प्लेटिनम के फ्रीजिंग पॉइंट पर है, तो उसके पर स्क्वायर सेंटीमीटर से कितनी लाइट एमिट हो रही है, ये है हमारा 60 कैंडेलास। क्योंकि जो ब्लैक बॉडी रेडिएटर होता है ये 60 टाइम्स ब्राइटर होता है हमारे स्टैंडर्ड कैंडल से। अब जो रेडियंट फ्लक्स किसी सरफेस पर आया है, ओके, इट इज इंसिडेंट ऑन अ सरफेस। सरफेस जो होती है वो इरेडिएटेड होती है। द फ्लक्स इंसिडेंट पर यूनिट एरिया एट एनी पॉइंट, इसे हम लोग कहते हैं इरेडियंस, और ये मेजर होता है हमारा वॉट पर स्क्वायर मीटर में। तो इरेडियंस इज इन वॉट पर स्क्वायर मीटर। इसका जो फोटोमेट्रिक इक्विवेलेंट होता है इरेडियंस का, दैट इज द इल्यूमिनेंस, जो कि मेजर करता है द लुमिनस फ्लक्स विच इज इंसिडेंस ऑन एन इल्यूमिनेटेड सरफेस। सो वी कंपेयर द रेडियोमेट्रिक एंड द photometric, right? So we are comparing these two things. The quantity of light emitted. So the quantity of light which is emitted, this is the radiant flux. And how is it measured? It is measured in watt, which is barabar joule per second, and this is equivalent to the luminous flux which is measured in lumen, LM. Okay, so intensity of light, which is the light emitted per unit solid angle, as is this, the steradian. So light emitted per unit solid angle. What it is? This is radiant intensity, which is watt per steradian. Equivalent is luminous intensity, or we measure it in candela, lumen per steradian. Okay. Third is the light reflected. No, third is the light which is per unit area, which is incident on a surface. So light per unit area incidence at surface. So if we measure it in watt, which is light per unit area meter square, sorry, this is meter square, we call it irradiance. And if we measure it in lux, which is lumen per meter square, this is illuminance. Okay, now the other thing is with now the light which is uh, falling on it. Okay, now the light which is reflected or emitted by a surface, light which is reflected or emitted by a surface in a given direction per solid angle per unit area, per solid angle per unit area. What this is? This is radiance. Okay, so watt, how we measure it? Watt per steradian per meter square, or if we call it luminance, it is candela, because candela is lumen plus steradian per meter square, right? So this diagram or this table is very important because it will tell you everything about it. Okay, now there is one more thing, that the illumination of a surface, that how much is. So the illumination of a surface also depend upon the angle of incident light to the surface. Okay, so this illumination is directly proportional to the angle of incidence, directly proportional to the angle of incidence of light. Like light is falling perpendicular on a surface, there will be a good angle of illumination. And if light is falling at an angle 0 to the surface, there will be no illumination. And this is called as the cosine law. This is the cosine law. Thus E, illumination of a surface, बराबर I dot cos I upon d square. This E is the illumination, I is the luminous intensity, okay. This is the angle of incidence, and distance between the source and surface. More the distance, lesser will be the illumination between source and surface. Uniformly diffusing surface is one in which the light reflects equal quantity in all the direction. Okay. Now, in addition, if it reflects all the light which is incidence, it is said to be a perfect diffuser. So, what is a perfect diffuser? There is one terminology called as the perfect diffuser. So, perfect diffuser in one which reflects all the light. Each reflecting point on such a surface, it behaves as a point source of light because it emits light in all the direction. ओके सो अगर मान लो ये एक पर फ्लूइड डिफ्यूज़र है तो हर एक पॉइंट जो है ऑन दिस सरफेस इट विल बिहेव एज अ हाउ इट विल बिहेव एज अ सोर्स ऑफ लाइट. ओके सो दिस इज अ perfect diffuser. Now the each reflecting point on such a surface, it behaves as a point source of light. The luminance at any point on the surface is defined as the luminous intensity per unit projected area in a given direction. Luminance is candelas per meter square. Candela is watt per lumen per steradian. The radiometric equivalent radiance, it is measured in watt per steradian per meter square. Okay, this is all we have read. Okay, one important thing is that this candela, it measures light which is reflected or emitted in only one direction. Light emitted in only one direction. Okay, and not the total amount leaving the surface in all the directions. Now there is one more unit called as postal. Okay, so a luminous flux of 1 lumen per square meter. 1 lumen per square meter. This is 1 postal. There is another unit that is called as the Troland. Now this is a measure of retinal illumination. इसमें हम लोग रेटिना का illumination नापते हैं. जब a surface luminance of 1 candela per square meter is viewed through an entrance pupil. This is Troland. Now the last topic of this chapter is the automated perimetry. what does the automated perimetry says that it measures the light sensitivity of points on the retina, and how it is by the ability of the patient to perceive the stimuli of varying intensity. Now the standard background illumination on most of the perimeter is 31.5 ASB, that is the apostle. Apostle is 1 lumen per square meter. Candela, it is 1 lumen per steradian, but apostle is 1 lumen per square meter. So it is a more practical way of measuring things. So the light stimuli which is given in the perimeters, it vary from 0.8 to 1000 apostles to 10,000 apostle. So this range, if we use it in log, this is 51 dB. All right. So here the chapter comes to an end. Thank you.